Chapter 1.10.4 Pod Scheduling Readiness. Here is a short summary about the article. Kubernetes version 1.30 introduces pod scheduling readiness, utilizing scheduling gates to control when a pod is ready for scheduling. This feature allows configuring readiness criteria at pod creation, addressing issues with miss essential resources, reducing unnecessary scheduler churn. Okay, that was the short summary. Let's have a deeper look into the contents. Pod Scheduling Readiness. With the release of Kubernetes version 1.30, pods, previously considered ready for scheduling upon creation, now have a refined mechanism to control their scheduling state. This development addresses issues where pods are stuck in a miss essential resources state, unnecessarily taxing the scheduler and related tools like cluster autoscaler. By using the spec scheduling gates attribute, users can manage when a pod is ready for scheduling, streamlining operations and reducing inefficiencies. Configuring pod scheduling gates. The scheduling gates field lists criteria strings that a pod must meet before it's deemed schedulable. These criteria are set when the pod is created, either by the client or during admission mutations. Once initialized, scheduling gates can be removed in any order, but adding new ones after creation is not permitted. Usage example. To mark a pod not ready for scheduling, use scheduling gates in its manifest, e.g., pod/pod- with -scheduling-gates.yaml. Check its state. Scheduling gated. Once ready, remove scheduling gates by reapplying a modified manifest, e.g., pod/pod- without -scheduling-gates.yaml. Confirm empty scheduling gates field and expected transition from scheduling gated to running, given no CPU, memory requests. Code example. This code defines a Kubernetes pod named testpod with two scheduling gates named example.com/foo and example.com/bar. It contains a single container named pause that uses the image registry.k8s.io/pause:3.6 to run. The pod will not be scheduled until the scheduling gates are cleared. The code, kubectl getPod testpod, is used to retrieve information about the pod named testpod from the Kubernetes cluster. This command helps to check the current status and details of the specified pod, such as whether it is in a running state or if there are any scheduling gates present. The code snippet is displaying the status of a pod named testpod, which is currently not ready for scheduling as indicated by the status scheduling gated. The pod has not yet started running, as indicated by 0/1, no restarts have occurred, and the pod was created 7 seconds ago. The code, kubectl getPod testpod ojson path equals spec scheduling gates, is querying the Kubernetes cluster for the scheduling gates set for the specified pod named testpod, and returning the output in JSON format. This command allows you to check if there are any scheduling gates configured for the specified pod, which may affect its scheduling status in the cluster. The code provided is a JSON array containing two objects with the key, name, and values, example.com/foo, and example.com/bar. This code could be used to define specific names or identifiers for different entities within a system, potentially for referencing or categorization purposes. It represents a simple data structure that can be easily parsed and manipulated in a programming context. This code defines a pod named testpod with a single container named pause, using the image registry.k8s.io/pause:3.6. The pod does not specify any resource requests for CPU, memory, indicating it will not be subject to scheduling gates. This pod is expected to transition from a scheduling gated state to a running state once it is ready for scheduling. This code uses the --l command to retrieve the scheduling gates field from the test pod using JS onPath output formatting. The output will display the current scheduling gates configuration of the test pod, indicating whether it has any scheduling gates present. This command is used to monitor and manage the scheduling constraints of the pod, allowing for proper scheduling decisions to be made by the Kubernetes scheduler. This code is using the --l get command to retrieve information about a specific pod named test pod in wide output format. The wide output format displays additional details about the pod, such as node name and IP address. This command provides a more extensive view of the pod's current state and location within the cluster. The code snippet displays the status of a pod named test pod, indicating that it is ready with 1 out of 1 containers running. There have been 0 restarts. It is currently running on node 2 with an IP address of 10.0.0.4, and it has been active for 15 seconds. Observability. The new --gated label in the --scheduler _pending _pods metric distinguishes between pods that are deemed unschedulable after scheduling attempts and those explicitly marked as not ready. Use --scheduler _pending _pods q equals gated to access this specific metric data. Mutable pod scheduling directives. When scheduling directives of pods are updated, they can only become more restrictive. This is achieved by allowing updates that reduce the set of nodes a pod can be scheduled on. Specific rules govern how. Spec. Node selector and spec. Affinity. Node affinity can be modified. Node selector can only have additions. Any empty node selector terms are allowed to be set, while pre-existing terms only allow additional node selector requirements without changing current match expressions or field expressions. The process hinges on how clauses in required during scheduling ignored during execution. Node selector terms are handled. OR logic applies to these terms, contrasting with the in logic in node selector terms, where you can only add new expressions. Changes are less restricted for preferred during scheduling ignored during execution, allowing any updates since these terms are non-authoritative and not validated by policy controllers. Hence, preferred terms have flexibility in updates.